Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this lesson, we'll be looking at the concept of risk and analyzing engineering economics for plants. Now, most comparisons of profitability are going to involve some sort of rate of return on investment, and generally your management for your company will provide a benchmark rate or a hurdle rate. And this is the rate of return that should be used in comparisons. This is the minimum acceptable rate of return, and often called the MARR. Let's think a little bit about an example, and this one is directly out of the textbook by Turton et al. And a company has been asked to consider two alternatives. And so the vice president is looking at these and thinking about them. And one says you could make a new product. It's not been produced on a large scale before, but you have done it in pilot plant, and the products were sent to potential customers. The customers were interested, but they are going to need more material to fully evaluate whether it will work for them. The calculated return on investment for that plant is 33%. A second option is to build another plant similar to what you already have, but it's going to be in another region of the country to meet increasing demand. And you already have a dominant market position for this product, but it's going to be similar to what you already have. It would involve a little bit more computer control, and you will be having to pay attention to what upcoming environmental regulation changes might be. And for this project, the rate of return is 12%, excuse me. So what should you do as the VP? Option 1 has a really high return on investment, and it opens up possibilities for new product lines and possibly growing your customer base. But option 2, you're going to be continuing service in a market that you already have a well-established market position. You know the manufacturing costs. You're going to decrease your transportation costs because now you'll have an additional facility in another part of the country. The technology is mature and well-known. There's little risk associated with this one. So ultimately, what this VP decided, we have little choice but to expand our established product line. If we fail to build these new production facilities, our competitors are likely to build a new plant in the region to meet the increasing demand. They could undercut our regional prices, and this would put at risk our market share and dominant position in the region. The internal rate of return on a mature investment may be much lower than the internal rate of return on a new or risky technology, and yet you may go with that lower rate of return. So it isn't purely about these numbers. As engineers, we like to be able to quantify our values and how much risk is there? What's the worst or best case scenario for these situations? In fact, if you look at, for a typical plant over a 10-year life, what the forecasts are compared to what we budget, the cost of fixed capital investment could be as much as 10% high, 25% low. Construction time, we could miss by minus 5% or over plus 50%. And all of these, look at this maintenance cost, up 100%. Inflation rate, we could miss that by double. Interest rates might change working capital, the salvage value, and our profit. All of these have variability to them. We want to be able to quantify what this risk is. So this is necessarily inexact. We're going to be doing it by kind of combining the historical data that we do know and looking at some key economic parameters that might predict trends for the projected life of the process. Now, these are going to be beyond the scope of this course, but the things that you might want to consider is, does it look like the supply and demand will, change in the next few years? What about labor costs, or energy costs, or interest rates? Or technology could change, or even worse, political upheaval. A company in some parts of the world has found that their facilities have been seized by the government. So we want to have ways of quantifying these. In the next few lessons, what we will be looking at are some of the techniques that are used to quantify this risk. We'll be looking at scenario analysis, sensitivity analysis, and some probabilistic techniques. So thank you very much for your time.